Yes, sir.
I'll share the presentation. Let me know once it's visible for everyone.
Yes, sir. It is visible.
Okay, all right. So first of all, I'd like to thank ma'am and everyone to give me this wonderful opportunity to speak here. Uh, our today's session is going to be with the generative AI with the rise of LLM. Forgive my throat. I'm having a throat infection for some days. Yeah, let's get started. So a little bit of introduction as ma'am has already given. But my name is Dhruman Badeshi. I'm co-founder and CTO at Kevit.io. I have 8+ years of experience in industry working across multiple domains. Let's get started on and discuss what we are going to take away from today's session. So for today, the key takeaways are to having an introduction of AI and machine learning. What is AI? What is machine learning? What are the AI terminologies? Nowadays, you must be hearing multiple terminologies thrown around. So let's get a grasp on what is AI terminologies. What are the neural networks? What are the transformer models? What is an LLM? And how you can customize LLMs? What are the AI agents? And some of the case studies. So we'll discuss in this session with some in-depth technical knowledge of the topics. You will take away with the understanding of how thing works and how you can leverage the LLMs for your own use cases. Moving forward, let's start with the introduction to AI and machine learning. So first of all, what is artificial intelligence? What is AI? So AI refers to the simulation of human intelligence in machines designed to think and act like humans. So basically, we teach machines to think and act like humans. Now, what is machine learning? So machine learning is a subset of artificial intelligence that focuses on building systems that learn from the data to make decisions or predictions. So basically, we are building some systems which reads the data, which learns from that data and makes some prediction. So that is machine learning, which is a subset of artificial intelligence. Now, the difference between artificial intelligence and machine learning. So first of all machine learning is and can be called artificial intelligence, uh, not all AI is machine learning, right? So, for example, LLMs like GPT-4 are a specific application within machine learning focused on a language. So that is a keen differentiation that we have to make. Moving forward, let's define artificial intelligence. So first and foremost, it mimics human intelligence process. So whatever we think as a human, whatever we act as a human, it tries to mimics that. That is why it's called artificial intelligence. It includes activities such as problem solving, recognizing different patterns, and understanding the language. The language, as we are speaking and understanding with each other right now, that is not an easy to understand or easy to digest for any machines. So that is where the artificial intelligence comes in place. It encompasses reasoning, learning, perception, and language understanding. So basically, in a nutshell, AI systems can perform tasks that are typically required for the human intelligence, which requires reasoning, which requires learning some new skills, which requires to have a perception of how the things works, and it might require the language understanding. It has a larger life use cases from healthcare, diagnostics to autonomous vehicle, customer service chatbots. It could be a number of use cases that serves the artificial intelligence serves those kind of use cases. Moving forward, we have let's define the machine learning. So first and foremost, machine learning, as I mentioned, is a subset of AI. So not all all machine learning is an AI, but not all AI is a machine learning. It focuses on data-driven algorithms. So machine learning typically focuses on data-driven algorithms. It reads the data and it acts and predicts something from the data. It enables the systems to learn and improve from the experiences. So unlike traditional programming, machine learning models learns patterns from the data. It might take actions from that data and it might improve over the time from that particular data. There are three majorly three different types of learning, like supervised learning, unsupervised learning, and reinforcement learning. We'll discuss this in depth, but just to give you an overview, a supervised learning is learning from labeled data. So the data that the machine is learning from, it's already labeled. Unsupervised learning, where the data is not labeled, but machine still tries to find the patterns from the data. Reinforcement learning is similar to having a learning where we learn from rewards and punishment. For example, if we learn to ride a bicycle, the reward is the joy, and we can say the punishment is if we fall off the bicycle, right? So that is the kind of a reinforcement learning. Moving further, let's discuss what can be called an artificial intelligence, right? So, an autonomy in decisions. For example, if an AI system can make independent decisions without the human intervention based on the predefined criteria and the learned patterns, it could be called an artificial intelligence. So let's say taking a decision of making a turn, right? So those are the kind of artificial intelligence that is being used in autonomous cars. So those, if AI is making any kind of autonomy decisions, it is called an artificial AI. If there is an adaptability and learning capabilities, it can also be called an artificial intelligence. The ability to adjust to a new data and improve over time without explicit reprogramming. So basically, we don't have to reprogram anything. The AI learns itself from the amount of data, and it can process and complex data processing. So basically, handling the interpreting a vast amount of data that are too complex for manual analysis. For example, let's say the stock market's data for last 5 years or even a 1 year, right? So that is a huge amount of data. If we set a human on the task to understand that data and take some decisions, it's very, very difficult for human to understand that kind of data. However, with artificial intelligence, we are able to handle that kind of data. So let's see what are the examples of AI and non-AI use cases, right? So virtual assistants, like we all have in our phone, Google Assistant or Siri, or the recommendation systems. Like if you're watching some movies in Netflix, they recommend you similar movies. Those are the examples of artificial intelligence. For the non-AI, we have like traditional software applications which follow the fixed instructions. For example, it has been programmed to like write a file into a directory. So that is a non-AI applications. We'll open for questions a little bit later on the session. I'll answer all of your questions over there. So let's take a look back a little bit in the history. Let's see how the AI became what AI is right now. So between 1950s and 1980s, we started having early artificial intelligence techniques. The word AI was actually used around 1956, if I remember correctly. At that time, we were having a symbolic AI and a rule-based system. So what is a symbolic AI, right? So the AI or artificial intelligence that we're talking about, it is focused on symbols, where the rules and logics were manually programmed. So it was not an strictly an artificial intelligence. However, it was able to understand a little bit of the context and execute based on that. This types of AI worked on exact data sets. It could not predict or understand things out of the data sets. And since we're talking about 1950s and 1980s, at those times, we were very limited by the computational power and data availability. So based on those restrictions, we were having a symbolic AI. So in the 1990s, we started seeing the rise of statistical models. So what are the statistical models? Those are the probabilistic models, which tries to identify the probability of if something can happen, right? So the introduction of probabilistic models and algorithms that could handle the uncertainty and variability in the data. So the real world data might be uncertain. Real world data might not have all the parameters that are needed to learn something. So the rise of probabilistic model overcome that particular issue. It allowed us to work with the real world uncertain data using those algorithms where it could calculate the probability of missing data or the future data. So basically, let's say if we are having and if we are looking for something inside the stock market and we would like to predict something. So based on the previous data, the statistical models or the probabilistic models would understand the previous data and predict something in the future. So those enabled more flexible and a little bit of scalable AI applications. Then from the 2000s up till now, we started seeing the emergence of neural networks and deep learning. This neural networks and deep learning allowed us to have multiple and insights of the data and allowed us to process a huge amount of data. Now in the from the 2000s we started having an enhanced computational power, and as the internet grew we started having data availability, right? So for the artificial intelligence the data is also important. So we started having increasing amount of data. We started having increasing amount of computational power. With the help of those two, we started to develop a kind of a network, which is called a neural network, which mimics the human brain, right? So in our brains, there's a neurons, and there are some connections between the neurons. So we tried and mimic that structure mathematically in computers, and with those structures, we were having some kind of success. So that there we started seeing the rises in neural network. Then comes the deep learning, which is the next evolution in neural networks that brought multiple layers to the plate. Like for the neural networks, we started having with a single neuron layer, but with the deep learning, we have multiple layers. It allowed it for processing complex patterns in a large data set, and this was a significant breakthrough in image and speech recognition. So we started seeing some use cases in the market where we are able to recognize some kind of images, where we started having a speech recognition softwares. And then as the years passed, we started having them in our phone. So those softwares and those use cases become more optimized with the time. So next comes the introduction of transformer-based learning. So neural networks were already started getting powerful. We started having a deep neural networks. We started having deep learnings, but however, that was still not enough for us to have a future breakthrough. So in 2017, there was an introduction of transformer architecture. The paper was released by Google Brain and teams. The lead researcher was Vaswani et al., and there is a team of five, seven researchers. They released a paper called "Attention is All You Need." Right? Uh, by the rids of it, it's a simple term. Attention is all you need. But this was an revolutionary paper in the machine learning field. So what is the difference with this transformers learning, right? So it revolutionized basically a natural language processing. So as I mentioned, whatever language that we are talking in right now, it's pretty easy for us to understand that. However, for artificial intelligence or for machines, it's very difficult to understand what I'm trying to say. Like in the movies we have seen, right? So different tones meaning different things in a natural language. So those kind of stuff we were not able to understand previously. With the help of introduction of transformer-based learning, we started to having that kind of use cases. Uh, and this basically laid the foundation for the large language models, the topic that we are going to talk today for. So the large language models, the transformers paved the way for the models like GPT and BERT. This model can perform a wide range of language tasks, from translation to content generation to understanding images to understanding the context, summarization, etc. So these are the kind of use cases that opened up from the introduction of transformer architecture. So before starting the next session, I'll pause for some questions. I saw someone having some questions.
Hello everyone who was asking the question. Now, as sir has given the permission, you can ask your question.
All right, I think we'll move ahead, and like if somebody is still having question, please keep it with you. We'll discuss in the next pause.
Yes, sir.
Okay, so moving forward, let's understand what are the AI terminologies. Like why do we need to understand what are the AI terminologies, right? AI is a rapidly evolving field and its own set of terminologies. Uh, so we need to understand the terminology in order to grasp the concept and in order to use the AI, right? So if you go out and use, I think everybody must be using Chat GPT and all, right? But if you want to explore a little bit of advanced use case, there will be some terminologies thrown at you which you need to understand before we start talking about the AI. So let's understand the basic terminologies first. Machine learning, we'll start with machine learning. So it's inspired by a human brain, consists of interconnected nodes. Uh, that process, sorry, so machine learning is a subset of AI that focuses on building systems that learn from data to make decisions and predictions. It utilizes algorithms to identify patterns and insights from the data. So as discussed, it can read the data, predict and like make predictions and decisions from the data. Neural network is like inspired by a human brain, as I was mentioning. So it consists of interconnected nodes called neurons that processes the data. These are the building blocks of the deep learning models. So neural network is a building block of a deep learning model. So what is a deep learning, right? It is again a subset of machine learning that uses neural networks with many layers. So it's called a deep neural networks. So it has multiple layers, while neural network is having a single layer. So it excels in the tasks like image and speech recognition due to its ability to model complex patterns. So when we are introducing multiple layers into a neural network, it starts to understand complex patterns. It starts to understand different intents and everything. So for that purpose, the deep learning started to understand like images and speech recognition. And mostly used terms nowadays, what is an AI model, right? We see GPT-4 or O1, O1 mini, etc. What are those models? So a model is nothing but a neural network which is trained on a defined data set. So, right, we take a neural network, we train it with some data set. Once it is trained, we store it as a AI model. So these nodes that are inside a neural network and their connections are trained as per the training method of data sets input. So that is what an AI model is. Basically, if you say what is a GPT-4o, it's simply a neural network which is trained on multiple data set, and it basically that's what it is. So that is an AI model. Now let's discuss some of the terms inside machine learning, right? So different types of learning that we are going to discuss right now. First and foremost is supervised learning, a simplest way to make a model learn, make a neural network learn. So basically, this model is trained on a labeled data. So what kind of labeled data is that? So it basically labels what should be the input and what is the desired output, right? So you define a labeled data, for example, you define that if somebody asks what is, let's say, what is the temperature right now in the India, it you always answer with a static reply. So that is a supervised learning. So that is a labeled data. The common applications for supervised learning are having a classification and regression tasks. For example, you train a model with a classification of what is, let's say, this is a real life example. What is a good cashew? What is a bad cashew? And what is the different grids of cashews, right? So we built a simple solution for a cashew sorting operator. So this is basically what a classification is. Then there is an unsupervised learning. This model works with unlabeled data where you are not actually labeling what should be the input, what should be the output. And it basically tries finding the hidden patterns or instinct structures that are inside the data, inside the data that you're providing. So that is a unsupervised learning. What are the common application? The common application includes the clustering of data. Clustering meaning if you want to find out what are the similarities between multiple data points, that is where the clustering comes in the picture. So that is the clustering. Then there comes a reinforcement learning. This is the one that I mentioned earlier, which gives you the rewards or the penalties based on the actions. For example, if you want, let's say, if you want to train your dog, right? So you tell it to sit. If he sits, you give him a treat. If he doesn't, you punish him. So that is a kind of reinforcement learning. With the AI, there is not actually a punishment like anything, but you just tell it that it didn't do a good job. So that is a reinforcement learning. The common applications for the reinforcement learnings are robotics. So we train the robots by giving them a reward if they are doing the right task, or giving them a penalties if they're not. Gaming and autonomous systems. So gaming, for example, you can train a model to play chess. If it loses, you give the negative actions, negative penalties basically. If it wins, you give him the positive rewards. And autonomous systems such as autonomous driving cars, autonomous sorting machines, etc. So that is a kind of reinforcement learning. Then there comes a semi-supervised learning. So this was the need of an hour where we don't always have labeled data to train the large models, right? Because labeling everything as a right or wrong or as a good or bad, it's not possible or not human. In order to tackle that, what we did, we combined both labeled and unlabeled data during the training. Uh, as I mentioned, having everything labeled is a very difficult thing to have. It might be scarce or it might be expensive to obtain that labeled data. So for that, what we do, we find some good quality of data, we label it, then we pass the other data, which is as unlabeled as it is. So that makes it a semi-supervised learning. So these are the basic three or four types of machine learning: supervised learning, where everything is labeled; unsupervised, where nothing is labeled; semi-supervised, where some data is labeled, some is unlabeled; and reinforcement learning, where we give positive reward or penalties based on the actions. Going forward, we have some advanced AI concepts. I think everybody might be knowing this, but let me quickly go through each of them. So natural language processing, it's a field of AI focused on interaction between computers and human languages. The applications are a huge of this field. It's like language translation, sentiment analysis, and chatbots. Sentiment analysis, meaning if the user is happy or sad or angry while discussing this topic. It's heavily used in customer-centric platforms where the customer feedbacks are mattered. Then there's a computer vision. It's a field of AI that enables the machine to interpret and understand visual information from the world, right? So basically, image recognition, object detection, autonomous driving. So everything, every part of that comes under the computer vision. Then we have generative AI, the one that is in the budget right now. So it's an AI system that can generate new content, right? It's straightforward as that. If AI is generating something new, it's generating AI. The context can be, the content can be text, images, music, anything, right? Nowadays, we started seeing very good models, um, very good AI models, which are generating images and videos as well. So those are the example. Those are the generative AI models. The examples we already know, GPT, BERT, etc. And then comes the large language models. So generative AI is a common concept, but large language models are the one that facilitates the generative AI at the moment. So these are the AI models that are trained on the vast amount of data to understand and generate a human-like language. So basically, they are trained on a huge amount of data. That's what makes it large language models, right? So that's large for. And for the applications of LLMs, we are already knowing it has a deeper understanding of languages. It can generate the data. So those are some of the applications. Now, some of the practical AI terms that is going to be used when you are interacting with multiple models in the wild, right? So let's start with the inference. This is an important one. So please pay a little bit of attention to this one, because if you're going to dive a little bit deeper in the artificial intelligence, these are the words that you're going to play with. So inference, let me explain what an inference is. Inference is the process of using a trained AI model to make predictions or decisions based on the new input data. So for example, you are firing anything or you are giving any queries to ChatGPT, that is doing the inference. So we already have a trained model. We already have a trained model with the data. You are giving a new input to that trained model and asking it to make predictions or decisions. That is a inference. So inference is used in real-time applications such as virtual assistants or recommendation systems, or basically anything that you want to work with AI. So those are the inference. Then comes bias and variance. So this is an important point to understand to evaluate a model. So what is a bias? Let me explain that. So bias simply means sticking to the training data and not thinking out of the box, right? So whatever training data is given to the model, if the bias is higher, model will not imagine anything out of the data, anything out of the box. It will just stick to the whatever the training has been. Now, variance is the opposite of what the bias is. It's an imagination of a model which varies from the training data. So whatever training has been given to a model, variance is a variance actually tries to stay out of that, tries to think out of the box. So imagine more content. So simple example for bias and variance I'd like to take is like we trained a model to identify and draw a picture of dog, right? So let's say we gave the model a huge amount of data on the pictures of dog, and it is capable of drawing the pictures of dog. Now we are asking this model to give us the picture of cats, right? So cat is not in the training data. So what happens if a model has a greater bias? Even if you are asking for a cat, the model keeps drawing dogs, even though model knows that it's a wrong answer. But it is biased towards the data that is already trained to it. That is why it keeps giving you dogs, even if you're asking for cats. But if the model has a higher variance, it will draw weird animals. Like it doesn't know what a cat looks like, right? But it will try to draw some weird animals. It may or may not look like a cat, but it looks very different than dog. So that's a variance. Now, in order to have a good model, we need a balance between bias and variance. Simple reason is that we want a model to stick to the realistic data. For example, if you ask a model, how can I fly? It should not tell me that I should start flapping my hands. It should know that I cannot, as a human, I cannot fly. And as a variance, it should also have a good amount of variance so that it can imagine new things out of what the current data, current training it has been given, so that it can tackle more complex questions as well. So this is bias and variance. Next comes the temperature. Now, temperature is a parameter that controls the randomness of the AI's output during the text generation or during the generation, right? So this controls the randomness, meaning temperature actually controls models bias and variance. uh, it tells models whether to imagine more, or it tells model whether not to imagine anything and stick to the data that it has. Generally the temperature is measured between 0 to 1, so it's in a fractions. Generally 0.5 temperature, meaning the AI model will try to stick to the data as well as imagine a little bit. But if you lower the temperature, it means that the model will be more deterministic and focus on the output, which output from the training data that it has, and it sticks closely to the most probable next words, right? With a higher temperature, model with a higher temperature, it means that increased creativity and variability. It allows the model to have more diverse and unexpected response. However, as a human, if we understand that response, we might see that the responses are not very logical, or responses are not very on the line that what we've expected. So that is a temperature. So having a good balance for temperature as well is also necessary, but it can vary from the use cases to use cases. For example, if you are learning or if you are working with a model where you absolutely need the data that is trained itself and not anything else, for example, in the healthcare kind of use cases, where any chances of error might be a situation of death and life. In those cases, we need the temperature to be 0. So model should stick to the data that has been trained on. It should not imagine anything else. However, for the creative fields, right? For example, writing new poems or generating new music, it should imagine a little bit. That's what makes it fun. So that's the temperature. It's a way to control the randomness in the AI models generations. So next comes the ethical AI. Now, what is an ethical AI? Why do we need it? Right? So we are using AI every day. But ethical AI is a practice of designing and deploying systems that are fair, that are transparent, and those are accountable. Now, why do we need fair, transparent, and accountable? Right? We are relying more and more on artificial intelligence nowadays. In order to continue our reliance on the artificial intelligence models, we need them to be fair. So they should not be biased on any particular political party or anything like that. They should be transparent on where they are getting the data from and where they are how they are generating the data out of. They should be held accountable for their actions. So that is a part of an ethical AI. We need to consider the bias mitigation. We need to consider about the privacy protection of the user's data. We need to consider about transparency and accountability when we talk about ethical AI. This is very important for us to build a trust in AI technologies and ensuring they benefit the society without causing harms. Right. So that is what the ethical AI is. I'll again pose for some questions if anybody is having any questions. Then we'll start with the neural networks. Okay, let's continue the neural networks. So basically, as we saw in the history, neural networks are what started what started the artificial intelligence in a mass. So let's start understanding the neural networks and what they are. So what is a neural network? First and foremost, it mimics the human brains, like how as a human have neurons in our brain. The neural network tries to mimic that brain. It basically learns from the training data. And now the components of neural network we discuss. Let's discuss about neurons, connections, and weights. So both basically, neurons are a basic nodes of computation. It computes the output of whatever the input it is given. Connections are the interconnections of neurons. So not a single neuron is not capable of generating an output. So it needs interconnection and passing the data to another neuron. Each of the interconnections uh, has a certain amount of mathematical weight through which the data is passed along to the next neuron. Now, after the data is computed from the input, the weight determines at which next neuron will get the data. So that is the weight. Now it can consist of a multiple layers. As you can see in the diagram, there are input layers, there are hidden layers, and then there are output layers. This is basically a deep neural network where there are multiple layers, not a single layer. So multiple layers such as input layers. So you can see the images. As I mentioned, a layer is a multiple neuron which may or may not be interconnected. So a single layer might have interconnection to its own, or it might not have interconnection to its own. But they are definitely connected with the previous or the next layers. So if it's not connected with the previous layer, it becomes an input layer. If it's not connected with the next layer, it becomes the output layer. Now, neural networks are multiple layers of interconnected neurons, such as input layers and etc. So each and every neuron contains an input activation function, which does the computation to carry forward the data across the neurons. So as you can see, each and every neuron has an input which accepts some data from previous neuron or from the input. It does some computation, that is an activation function. It determines what to carry forward to the next neuron. And based on the weights, it will be passed along to the next neuron. Now, going a little bit further, let's see what a real life neuron looks like as versus what an artificial neuron looks like. On the left, you can see the real life neuron. It has a cell body, some axon terminals, some nucleus. On the right, you have a structure of an artificial neuron. It's basically a mathematical function which accepts some inputs along with weights. It has its own bias, and then there is an activated function which calculates some kind of outputs. Now, if we compare the neurons, we can say that the nucleus is a bias. In the real life neuron, the nucleus is a bias for artificial neuron, which is actually trained based on the training data. And going further, the inputs and output is like axon terminals, which accepts some kind of input. In real life, it accepts the electric signals, and in artificial neuron, it might accept some kind of input. The weights are, as I mentioned, what is calibrated from the training data. The activated function is fixed for the whole neural network. It computes the output, and once the output is computed, based on the weights, it is given to the next neuron. So this is basically an anatomy of a neurons. Now let's discuss a little bit about transformer models. Now, by the definition, if we go, transformer models are a type of neural network architecture which was introduced in 2017 by Google Brain team. There was a specific key innovation which allowed the transformer models to be hugely different from what a neural network is, right? So it's called a self-attention mechanism. This allows the models to weigh the importance of different part of the input data. It enables it to capture long-range dependencies more effectively. So major difference we will discuss in depth. And the major difference that I can tell from the transformer model is that unlike neural networks, which processes the data sequentially, transformer models can process entire input simultaneously in a parallel. This allowed a greater parallelization and efficiency. So let's see the architecture of a transformer model. So what is a transformer architecture that the Google engineers presented, right? So it consists of an encoder and decoder structure. Now, what is an encoder? The encoder takes the input data, processes it, and creates an internal representation that is similar to the model. That is not similar, but that is defined to the model. So there is an internal representation of the data that is generated by the encoder. Same way we have a decoder. Decoder again uses the internal representation as an input and it generates the output data. So same way that we encode decode content, encode decode messages in computer engineering or like our fields. The same way this model started encoding the data, converting it to some intermediate form, decoding the data and converting into outputable form. So that is a encoder decoder structure. Now encoder decoders are not new in the market. It was there before a long time, right? So what made a difference? That is a self attention layers. The self-attention layers is actually a mechanism to weight the input elements. So each encoder and decoder layer contains a self-attention mechanism, which allows the model to focus on different parts of the input sequence. So basically, it allows the models to focus on a different part. So let's say we have 1 to n encoders. Each of them can just take a single input. Let's say we break down the how are you. So encoder one, for example, takes how, encoder two, for example, takes R, and encoder three, example, takes U, right? So it breaks down the input, provides into the encoder, and it can focus on the different parts of the input sequence. So it can focus on similar parts, individual parts of the sequence. The same thing can happen when generating the output, right? So when we try to decode it, the decoder will again take one input from a single encoder. It will try to decode it into a real life use cases. The same goes and on. So that is a self-attention layer, which allowed it to have a parallelism, which allowed it to have to focus on a single uh, part of an input. Now this created a problem, like it doesn't know what is a position of input, what is a position of output, which are very necessary to generate a meaningful output. If the scrambled output of how are you translated in other languages presented to you, you are not able to understand what is the output of how are you. So in order to in order to fix this problem, they introduce a positional encoding, which incorporates the order of data in the sequence. So since transformers like do not inherently understand the order of data, the positional encoding was added to the input embeddings to provide information about the position of each element in the sequence. So basically, it provides what is the sequence of each and every element. So this is a basic transformer architecture where we have multiple encoders, multiple decoders. Input is broken down and they are provided to different type of encoder. They converted it to intermediate representation. and then a decoder takes that intermediate representation and converts it to real output data. Now let's understand a little bit deeper on what is a self-attestation or self-attention mechanism. As this was a revolution, so let's understand what was the purpose of self-attention. It basically enables the model to consider the relevance of different words in a sentence relative to each other. It improves the understanding of context and relationships. So it captures the relationship between words. It tries to understand that relationship and it improves the understanding and the context of those words. Now, we might be asking how it works. So there are three words: queries, keys, and values. What are these three? What does this mean? So each word in the input that we are giving, it is transformed into three vectors: a query vector, a key vector, and a value vector. So what is a vector? Vector is basically a representation of a point in a n-dimensional space where where the point is located. We can point it, we can direct it from 0, 0, 0, right, from the root node. So that is a vector representation. So queries, keys, and values transformed into three vectors. The attention score now then is generated or calculated using the dot product of the query. So all of this, all of the three vectors that we have, we create a dot product of that, and we calculate the weight based on that. Now, once these weights are applied to the values, it produces efficient output where it captures the relationship between the words. It understands what is the position it needs to do, and it outputs the exact sentence that we are expecting out of it. So this is what did the wonders for the technology. Now, how do we benefit from it? First and foremost, it handles the long range dependencies. So your relationship between words or your relationship between two things can be very far apart in your data, in your training data. It can be from it can be the first word and the last word. But because it has a vectorization and a dot product of it, because it has a self-attested attention, it can handle the long range dependencies. So it can understand the relationship between the words that are far apart in the sequence. It enables the parallel processing, right? So as I mentioned, unlike neural networks, the transformers can process all the words in a sequence. Transformers can process all the words in parallel, leading to a faster training times. So as we saw in encoder and decoder section, we don't need to pass single stream of data to the neural network. We can break it down and pass it a small chunk of data to single encoder. So that way, it allowed us to have a faster training time, a faster understanding, and a better understanding. Now, with all of those advantages, what do we get? We get a scalable transformer model, a scalable neural network, which can efficiently scale to handle a large data sets and a complex models, which was previously not possible because we had to feed the data in sequence and the models were taking a long time to train based on the data. So since we have a scalability now and a parallel computing, it is more suitable to train on a massive amount of data. Again, parallelization, as I mentioned, the architecture allowed for a parallel processing of input data so that it significantly reduced training times compared to a sequential model. Then comes the flexibility. Now, since we are not just generating the text, and we have this new revolutionary architecture, it supports a wide range of tasks beyond just natural language processing. It can generate and process images, it can generate and process audios, it can generate and process videos. As we are seeing right now in the market, we have a lot of new models coming out which are able to process audio, video, which are able to generate audio, video based on a single prompt from you. So that gave us the flexibility. Now, after having scalability, parallelization, and flexibility, now we have a foundation for our large language models. Now, why? As I mentioned, large language models, it has a huge amount of data sets that needs to be trained. So having a parallel computation available, having a scalable computation available, and having a flexible computation available, it allowed it to have large language models. Transformers are basically the backbones of advanced LLMs such as GPT and BERT. These are the two names that you might have heard. Uh, it enabled them to perform a variety of language related tasks with a high accuracy. A little bit of unknown fact, the full form of GPT, it stands for Generative Pre-trained Transformer, and which is GPT is basically prioritized by OpenAI. And then we have BERT, which is heavily worked under Google. So BERT stands for Bidirectional Encoded Representation of Transform. So these are some of the words that we might not be familiar. We might be using a lot, but we might not be familiar. So it's a fun fact. Going forward, let's discuss some of the real world application. This slide can be anchor for you on where to use or where to consider a neural network or where to consider a transformer model. So for example, if you're going for a simple image and speech recognition, neural network based models are good. You don't need a transformer based model. If you're doing a predictive analytics, for example, as I took an example of stock market, we have to predict what is the trend going to be in the, let's say, next quarter. We can do that with neural network. We don't need transformer based model. But where do we need transformer based models? Where we are doing a language translation, where it's important to understand the context as a large. That is where the transformer model comes. Where we do a text generation and summarization. Again, here see that the context mattered on what we are discussing. At that point, the transformer models comes into the picture. And nowadays, we are seeing a lot of chatbots and virtual assistants. That is where the transformer models shines. Okay, so that is basically the real world application of what a neural network is, what a transformer model is, and when to use which. Now, I'll again pause for Q&A. If anybody is having any questions, please let me know. Then we'll discuss what is LLM. All right, we'll continue with what is LLM. So yeah, as we discussed, the transformer architecture was such a breakthrough. The introduction was LLMs was a pivotal advancement in AI. Now, what LLM is, it is a capable of understanding and generating a human-like text and now multimedia as well as we are seeing in the market. So a little bit of history of LLM in 2018, I think GPT-1 was released, but it was not good understanding model as compared to the neural network based models. It took up to 2020 when the OpenAI first released GPT-3. So this LLM finally supersedes any type of other neural networks and it becomes a king of LLMs, right? So GPT-3 was released on 2020. It has seen progressive updates on it. And yeah, basically that was it. LLMs now have transformed the various industries by enabling more natural and effective human machine interactions. We'll take a little bit of deeper dive on what is an LLM, their current state, their capabilities, and the applications that we are going to see from it. So let's start with defining what is a large language model. So what is an LLM, right? So we can define LLM as an advanced artificial intelligence model, which is designed to process, understand, and generate human language with high proficiency. So I just mentioned human language, but now it started to having images and videos, etc. as well. So basically, it can generate human understandable content. So that is what a large language model is. So its core characteristics are, first of all, the scale. Ideally, it typically contains billions of parameters. It allows them to capture intricate language patterns. So basically, if we are listening right now on the market, we are seeing like billions of parameters are trained. GPT-4o, for example, was trained on 400 or something billion parameters. So these are this is the scale on which the large language models are trained on. Then we have versatility, where it is the models are capable of performing a wide range of language related tasks without a task specific training. Right. So you don't need to train LLM how to write, for example, your assignment or how to write a report for you. LLM knows how to do that. Sorry, LLM doesn't know how to do it, but still it's versatile enough that it can emulate a natural language related task without a specific training. So that is versatility. And then there is a contextual understanding. It is able to comprehend and maintain the context over longer text span. So everybody has experience with chat gpt, right? If even if you are having, let's say, 30 minutes of chat history and it we're having 300 400 messages, even if you still ask chat gpt something, it will maintain the context or maintain the discussion that you have done on the previous messages. That is a contextual understanding. Now, what is the distinction from other AI models? What is a different from large language model? What is a different for large language models? So simply, the LLMs from a smaller models is a simple uh, differentiation by their size, their training data, and the broad applicability. So basically, the size of the large language models is, as the name suggests, large. It is the size is large because the training data's volume was huge, and because of the training data and the size, it has a broad applicability. It's not just to generate text. It's not just to generate content. It is also able to help you with taking decisions and all. So that is what the large language models are. Going further, what is the architectures and scale of a large language models? So first of all, every LLMs are based on transformer based architecture. So it is based on transformer based architecture, which utilizes self attention mechanisms for efficient data processing. Um, then the scale is on number of parameters. So the as I mentioned, the GPT-4 and the other models, those are different with the number of parameters. And GPT-4o, as I mentioned, was trained with hundreds of billions of parameters. So that is the number of parameter. Then there are layered structure. So it's a multi-layered neural network with the transformers. It includes the encoder, decoder layers that are process the inputs data and generates the output. And then there are scalability features. So this architecture allows for scaling up models by adding more layers and parameters without significant loss in the performance. So we are able to fine tune the model. Basically, this is where the term comes from, and add certain more layers and parameters to the model to make it feasible for your application. So that is basically the scalability feature of the LLMs. Then we discuss about the key capabilities of LLM, right? So natural language understanding, that is the first and foremost. You can tell it anything. You can tell it things which means something as a human language. It understands it. It comprehends the complex language structures, idioms, and contextual nuances. It is able to generate text for you and completions for you. Completion meaning if you're writing something like you have not written it fully, you just wrote it half, it will complete the sentences for you. It generates a coherent and contextually relevant text based on whatever prompt you are given, whatever input you are given. And it is useful for drafting, storytelling, more, and any many more use cases, right? So language translation and summarization was the first intended use cases of transformer-based model. So basically, it is proficient in translating between languages, summarizes lengthy documents into a concise summary. So, for example, you can take the transcript of the session, put it into a large language model, ask it to summarize what I was speaking. So it will be able to summarize it. And then there is conversational abilities. So LLMs that powers the chatbots, virtual assistants, it enables a more natural and effective interaction with the users. So you're able to ask it n number of questions with a natural language. So that is what the capabilities of LLMs are. Now let's discuss some ways to customize the LLM. I'll introduce some techniques through which you can get LLMs to answer as per your data. Uh, I saw a little bit in the previous session that these things were discussed, so I'll just go through it a little bit quicker. So first and foremost, fine tuning is possible. As I mentioned, you can add more layers to the model and fine tune it with your according to data. This is actually retraining a model with additional information. For that purpose, it's a very cost heavy operation. You first of all, you need a huge amount of data at your hand to retrain a model. Then to train it is a huge cost heavy operation. But however, after the training, the results that you want to get out of your models after fine tuning, it will give you much better and accurate results. The second one is retrieval augmented generation, short form is RAG, or nowadays called RAG. So what happens? You feed some additional information to LLM, which can be obtained from any number of sources, right? So it can be your text documents, it can be an API call, it can be any data from your sensors. So you give some additional information to LLM, then LLM generates a text for that query with that additional information, right? So you take a user's query, you get some additional information, you pass it to LLM, LLM will generate some text for you. So that is RAG. Prompt engineering, as ma'am was saying, we provide some additional information along with our query to LLM so that LLM thinks and behaves in a specific way. It can answer only with the trained knowledge of the model or whatever context you are giving in a prompt. So it like basically it cannot answer you how to open a bank account, for example. So these are the basic three methods of customization. Let's talk a little bit about RAG or RAG. So it's a retrieval augmented generation. This techniques combines LLMs with the retrieval systems to enhance their ability to generate accurate and contextually relevant responses. This involves retrieving information or documents or data from any external sources, using that information to inform the generation process. Now, the generation process is with the LLM, right? So we take the information from external sources, we pass it to generation process to LLM, and we tell it with a prompt engineering basically to consider whatever I've given you and consider that data as an input. And this was the original query. Generate me an answer from that. So that is basically how the RAG works. Now, what are the benefits of RAG, right? So why should one use it? It's not that cost heavy uh, compared to fine tuning, because fine tuning, let's say 400 billion parameters models, requires lakhs of rupees investment, while having a RAG system answer from your let's say document, it basically costs nothing, right? So that is RAG. uh, and uh, Apart from that, it improves upon the accuracy and relevance. So let's say by accessing a specific up-to-date information, the RAG systems can provide a more accurate and relevant responses compared to a traditional LLMs. Um, Same goes for reduction of hallucination in LLMs, right? So RAG helps the help mitigate the issues of LLMs generating a plausible sounding but incorrect information that is known as a hallucination. It grounds it by response to the actual retrieved data, so it reduces the hallucination. It allows you to access up-to-date information basically. So after a fixed knowledge cutoff, RAG can retrieve the latest information. For example, we can do a latest Google search, know who is the president of United States, and RAG can able to answer that. However, if we are not using RAG, the model will answer on whatever data it has previously trained to, not the current accurate data. So that is introduction to RAG. Going forward, what is a prompt engineering? I'll quickly go through it. So what is a prompt is basically serves as a bridge between user's intent and AI's output. So whatever you give to the user, to the AI, it is a prompt. How the AI model processes the prompt actually. This is a little bit of interesting topic. First of all, whatever sentence you are given it, it tokenizes it. It basically breaks it down into smaller token for processing. Then it gives it to encoder. So all the tokens are given to encoder, which converts the token into a numeric representation. This numeric representation is basically the internal representation of data. It does the probability distribution, so it calculates the likelihood of next possible words, and then it generates the output based on that. So it tokenizes. is encoded. It encodes the text. It does the probability distribution, and then it does the generation. So that is how a AI model process prompt. So now, why does an effective prompting matter, right? So if you want a quality response from your model, a clear prompt should be there. That's how you yield an accurate and relevant answer. It could be an efficient answer as well. So it reduces the need of multiple iterations or clarifications. For example, if you're asking your AI model to write your document, and if you are specifically asking it from the start with the prompt that you want it to be a professional document and not, let's say, a casual document, so it will use that kind of language throughout the document. But if you have forgotten to give it that particular instruction, what it will use a casual language to generate the document, and then again you have to reprompt it to give you a professional language document. So that is the case, and it is critical for tasks like customer service, content creation, data analysis. So for this task, you have to do an effective prompting. That's only how you get the output. Now, what happens if you don't do effective prompting, right? So the large language model can do a wrong interpretation of data. The data that you get out of the LLM might be incorrect. It can lead to unpredictable outcomes that, for example, one time you are getting some other calculations, the other time you are getting some different calculations, and the hallucination with the models can also happen. So those are the challenges with the poor prompting. Now let's see an anatomy of prompt. A prompt should contain a role, tone, context, task, example, and format. If you are following this anatomy, you are guaranteed to get better outcome out of your LLM models. So what is a role, right? You tell the LLM who is he, right? So you tell the LLM that you are an expert gym trainer, and I've given the example over here, right? So you tell the LLM that you're an expert gym trainer. So it gives the role to LLM. Then what is the tone? We tell the LLM how to respond, how he should behave, basically, right? So we tell it to use a proper professional language to answer. We don't want the LLM to answer in any kind of other language. We want it to be professional. So that is the tone of the LLM. Now we provide the context. Now, what is the context? We provide the things related to the task, right? So we provide the LLM that my age is 25, my weight is 90 kg, right? So this is the context that I'm providing. Then what happens? I'm giving it a task. You must give me a diet plan for weekdays, right? So this is a task case. Then we give it example, like what is a good example of an output. So for example, you can say I have to eat veggies every day. So this is an example of a diet plan, right? And at the end, we can give it a format. The format is basically how you expect the output to be. It could be any n number of formats. So basically, right now I'm giving it, you should give me bullet points for the days with each meals, right? So it will give me the output in bullet points. Now, instead of this, I can write any other things as well as a format of output. I can tell LLM to give me an output in basically, let's say, a JSON. That is also possible. So this is the anatomy of prompts. Now let's take it further. Let's discuss about AI agents. Right, this is a buzzword right now in the town. So we'll discuss what is an AI agent, how they work, and how they are useful. So basically, when we are giving a prompt to a user, a role to sorry, when we are giving a role to an LLM, we are giving a context to an LLM. The LLM ideally is able to understand what it needs to do, what he is, what is his backstory, and what is he expected to do, right? So once we make sure that LLM knows all of these things, that makes it an agent. So what is an agentic AI? How it works, right? So first and foremost, it works by having an autonomous decision making. The agentic AIs can evaluate the situation and make the decision without needing the constant human guidance. They use either a set of predefined rules or learn from the data to determine best course of action. A simple example is a virtual assistant deciding the best time to schedule a meeting based on your calendar and preferences. Right, so it goes to the calendar, checks your availability, and then confirms and creates a meeting in your calendar as well. So it takes a decisions, does some action. So that is an autonomous decision making. Now, task execution and goal achievement. You provide an AI with a goal, you provide an AI with some task to perform. Once it does it, that becomes an agentic AI. So this AI is designed to perform some specific tasks aimed to achieving a particular goal efficiently. Right? They can manage and execute tasks, schedule the meetings, organize workflows, or even more complex operations like managing supply chains. A simple example would be an AI system in a manufacturing plant that manages the inventory level. So whenever the supply goes down for anything, it will place an order directly with the configured configured supplier, and it will restock the inventory. So this is an AI agent specific with one task and one goal. It's his goal is to keep the inventory filled up to a certain level. So whenever it goes down that, it takes an autonomous decision, it places an order, and it ensures that your inventory does not deplete. The third one is interaction with environments and users. So like agentic AIs are continuously interacting with their environment and users to gather necessary information. These interactions kind of allow them to adapt their action based on the real-time data and user inputs. This ensures that they remain effective and relevant. An example would be a smart home assistant that adjusts the lighting and the temperature based on the time of the day or the user's activity or weather of your location. Right, so it can grab the data of the weather. It can check whether the person is inside the home, and based on it can check what the time is, and based on that it will take a decision to, let's say, turn on the AC or turn on the lights or turn off the lights, etc. So these are the this is how the agentic AI works basically. Some use cases, as I mentioned, like the virtual personal assistants. These are the advanced personal assistants. They go beyond simple tasks like setting reminders, right? They can manage your entire schedule. It can control various smart home devices and even anticipate user needs based on the past behavior. Uh, Say, for example, an enhanced Alexa, which only sets the reminder but also orders. Someone is on mute. So, yeah, sorry. Let's continue. Let's just take an example of an advanced Alexa, which is not just sets a reminder like the Alexa does currently, but it also orders the groceries from Amazon. It adjusts the temperature of AC. It updates you with the traffic proactively. Like it knows whenever you are leaving from home, it gives you a notification of the traffic. So that is a virtual personal assistant. We can have an automated customer service agents. Like these agents can handle a wide range of customer service tasks, from answering like common questions to resolving issues without a human intervention. This will lead to a faster response time and consistent service quality. Uh, we are seeing this use case in a while right now. Let's say a chatbot for an online retailer that can process returns, track orders, answer product related queries 24 by 7. This is happening with many of the huge companies right now. We can see some intelligent automation in the industries. Like in industry settings, an agentic AI streamlines the operations by automating multiple complex processes. It manages the inventory, it optimizing the logistics. This overall leads to increased productivity and reduced operational cost. A simple example is an AI system in a warehouse. Again, as I mentioned, that manages the inventory levels, coordinates with the suppliers, and optimizes the layout for efficient order picking and packing. So this is all possible with agentic AI with a specific goal in a mind, with a specific role set to it, with a specific optimization set to it. Now, the benefits, again, it increases the autonomy. and efficiency by handling the routine task and repetitive task autonomously. It's a significant boost for operational efficiency. It will allow the humans to focus on more strategic and creative tasks, enhancing overall productivity. Personalization and adaptability can be increased by learning from the users' interactions, their behaviors, and it will meet their individual needs. This personalization leads to more effective and satisfying user experiences. A simple example is a personal assistant that learns your daily routine, your preferences, and it will adjust its suggestion and action to better align with your habits. Next is enhanced user interaction support. Like these AIs provide more intuitive and responsive interaction, making technology easier to use and more accessible. The enhanced support leads to higher user satisfaction and engagement for brands. So that is the use case of it. Example would be a customer service AI chatbot that is providing the answer 24 by 7. It also understands the user's sentiment based on the user's inputs and tries to adapt the answers based on that sentiment. So that is for the user interaction and support. So in order to conclude the agents, basically I can say that they work independently. They take help of multiple tools available at their disposal. They interact with the real world and environments, and then based on all of the data, all of the inputs that they can get, all of the tools that they can use, then they take a decision to do something. So these are the autonomous agents. This is called the agentic AI. uh, I'm going to leave you with a chain of thought with this discussion, right? So imagine that you have multiple agents working in coordination, each having a similar task or similar goal to work for an organization. How powerful that can be, right? All right. So uh, there is a simple case study that we have made. So we'll quickly go through it since we are almost at the end of our time. So in the case study, we built a chatbot for one of our customer, which is Gulbenkian Foundation. They run the Gulbenkian Museum in Lisbon, Portugal. They had an interesting challenge for the museum, right? They wanted everyone to have a nice experience of the museum, but they had challenges of the language barrier, where they needed people who speak multiple languages present in front of the art pieces in order to explain it to them. The displays of the painting lack the interactivity if you are not with the guide. So basically, if there is no person explaining it, it lacks the interactivity. And the information about the paintings and the other information about the painting, etc., that were limited if you have someone going around with you, and if you don't have someone going around with you and explaining. So these were the challenges. To resolve that, we proposed a solution and we actually built a solution. The solution is simple. We developed a custom AI powered chatbot, which works inside of WhatsApp. You don't need to download any other app like the other things are doing right now. People comes to their museum, like you click the picture of a photo or art piece that you're in front of, right? You send that picture to AI, sorry, to our chatbot. The AI identifies which art piece you are in front of. That explains the users about that art piece in users language. It asks the users like in what language you want to understand it. So if user says, let's say, in Portuguese or in German or in Hindi or in English, the AI will respond according to that, and in that particular language, it will explain the art piece to the user. Now, what was the outcome of this whole experiment, right? This definitely benefited in terms of revenue or in terms of footfalls for the museum. The museum has reported to us with at least 30% more footfalls in a week. So 30% more people started visiting the museum. It reduced the cost of their guides around 20% because they were less occupied. They were actually focusing on some critical tasks. And the feedback they collected from the user were amazing. They were able to understand uh, what is able to do, and what it's able to do, and what they are seeing. So this was one of the experiment that we did with a customer where we titled it where AI meets the art. So basically AI is understanding the art for you, explaining it to you. So yeah, that brings it to end of my session. If you guys have any questions, I'm open for question.
Yes, thank you, sir. All the participants, sir is open to answer your questions. You can ask your queries now. Anyone having any queries?
I must have did a very good job if you none of you have any questions.
I think they are not able to unmute themselves. Let me change the settings.
Okay.
Yes, now have unmuted all. If you have any queries, you can ask now. I think there are no queries from anyone, so you have explained it very well.
Thank you, Dipesh. I hope everyone got something out of this session that will help you in
Definitely,
the real life.
definitely. So thank you for all the information about AI and especially in the large scale.
Thank you, Dipesh sir, for giving me this opportunity. Thank you, Jignesh sir, for this opportunity.
Thank you, sir, for sharing your valuable thoughts and the especially technical points that you have covered.
All right.
So, all right. So, as participants have no queries, let's end the session here.
Thank you all. Have a good night.
Good night, sir. Thank you. There is no photo session, so you can leave now. Everyone can leave the meeting now.